Assalamualaikum, dear students. Welcome to another demo about object-oriented programming. And today I'm going to explain a very important concept. This concept is called a pointer to objects and pointer to structures. You already know about structures in Introduction to Programming course. So in order to create a structure, you just type struct node. So this is one node. One node means one particular data, and it contains two different kind of data types. Int value, for example, in char alpha. I have declared two different types of variables within the structure. The syntax for creating the structure is that you type struct keyword, then the name of the structure. It's an identifier. Then the body begins and closes just like the class, and at the end you put the semicolon, and then you declare two different data types. So a structure is very different because it's called non-homogeneous data structure. That means you can group different data types together within the structure. As you can see in this one struct I called a node, it contains a value of type integer and another variable which I call alpha, and it's of type character. So if I want to create an object of the struct, I say node and let's say n. So I've created a kind of object from the structure called node, and if you want to initialize the data members of this structure, you can do with the dot operator n dot alpha and in single quotation mark capital A. So I have initialized this object alpha variable to be character A. So n dot value, and let's say you assign an integer value 100. The difference between a class and a structure is that data members by default are public. That's why I can access alpha and value with the dot operator within the main. Otherwise, if it was sort of private like a class, I would have not been able to do that. And if you want to display the values of the structure, I can then say n dot alpha space and n dot value and del. If I save this program, compile it, no errors, green line, and let's run this program. And as you can see, the alpha part of this object is A, and this is 100. You can also take input from the user if you want. So let me comment out this line. And for example, we want to say cout enter a character and then cn n dot alpha. So what happens is that alpha is not an independent variable, but rather it lives inside the node. So you use the dot operator. So you say n dot alpha means the alpha inside this object. Similarly, you can then say cout enter an integer and then cn and n dot. And now you can again simply display that, which I did before. I'm uncomment the line. Control is to save changes and just run the program. And let's say I put capital Z, and then for the value I type 200, and as you can see Z and 200. So this is something that you are already familiar in the Introduction to Programming course. And now let me talk about pointers. A pointer, like a pointer to an integer. If you want to declare pointer to an integer, you say int value is a variable, its value is 100, and if you want to declare a pointer, you put the star next to the data type, and then you name your pointer, and then after that you assign the address of the value, because a pointer is a special kind of variable which cannot store values directly, but rather it stores the addresses of some variable. So if I cout the ptr now, it would contain the address of this variable value. Whatever the address of this variable in memory is, we are going to see that on screen. So I'm going to run this program, and as you can see, the addresses are represented by the 0x hexadecimal number system. Addresses are represented in hex numbers. So this is an address of this variable in memory. It's the actual address of the memory. Right. So if you want to display the values of the variable the pointer is pointing to, then you can use the star operator in front of the pointer name and now it means dereferencing the pointer, that do not display the address but rather go to the address and get the value and display that value the pointer is pointing to. So I'm going to run this program again, and this time I have displayed the value 100 of the value the pointer is pointing to, and this is the address of that variable. So this is a sort of revision for you because you already know that. One thing that you must keep in mind is that if you want to create a variable, for example, float f, 12.3f, for example, and you want to create a pointer to this variable, the data type of the pointer must match the data type of the variable to which it is pointing. So you can't just declare an integer pointer to point to the floating point variable like int star p equals to ampersand f. This is invalid. The reason being that the data type of this variable f, whose address I want to store in p, is float, and the data type of the pointer is int. So the data type of the pointer must match the data type of the variable to which this pointer is pointing to. So if I compile this program, I hope we are going to get an error message. And as you can see, you cannot convert float to int in initialization. The problem is that this pointer p is pointing to a variable called f, and that f is of data type float and pointer is of data type int, so type mismatch. So if I change it from int to float, and now if I compile it again, there is no error, and this yellow message or exclamation mark, this is just a warning that you have declared a pointer but haven't used it. So if, for example, I want to see the address, I say p without a star, and if I want to see the value, we see p and l. So it will show the value, the address, and this will show the value at that address. So this star p, star is used in two cases. First, when you declare a pointer, and second, when you want to dereference the pointer, getting the value on that address is dereferencing. So let me execute this program again, and you will see the address and the value of the floating point value. See, these addresses are different, so because they are different variables in memory. Now let me talk about the let me comment out this code, and let's talk about pointer to structures. It's a bit the concept is the same. So for example, if you create a node and you say star, and now we have created a pointer. It's a pointer to the node object, so you can then assign the address of a node, but we haven't created any node. So if I create a node and I say node and obj, and I say, for example, nobj.alpha, and I say capital A, and nobj.value, and I say 100, and now I want to assign the address of this nobj to the pointer, because the object is of type node and the pointer star n is also a pointer. Let me change this to ptrn just to make it stand out that it's a pointer, and then I'm going to say ampersand nobj. So what I've done here, I've created an object of the structure called node. I initialized its data members, and then this is called the address operator. I assign the address of nobj, because if you remove the ampersand, that means a value. So we are not storing values in pointers, we can store addresses in pointers. So ptrn will store the address of this object, and I think if I this ptrn, and then we should see the address of this node in the memory, and 061 fe84, etc. So this is the address. If, for example, you want to get the values of the data members with the help of the pointer, and the data members of this object, which is alpha, and its value is capital A, and another data member of nobj is value, and its value is 100, and I want to get the values of alpha and value with the help of the pointer, the syntax is a little bit strange, and it says cout ptrn. You don't say star, ptrn, and then this operator, the arrow symbol, and then alpha. Similarly, cout ptrn dot value. So we use this notation, which is an arrow symbol. That means ptrn is a pointer, and we are dereferencing the pointer. Dereferencing means the ptrn stores the address of this object, go to the address and get the value of alpha. Similarly, ptrn having address of this nobj, get the address, go and get the value. So if I run this now, you should see capital A and 100. So this was the address, and now these are values with the pointer. So this is a pointer to this node, right? So you say node star, and let's say small node, and then say you new and then node, just like a class. You create an object of the class in two different ways, dynamic and static. This is an object. The new keyword allocates memory to the node from the heap, right? So heap is part of the um, address space of the process. It's just a special memory location. It means as long as the program is running, you have access to those memory, those chunk of memory, right? And if now you want to store, initialize the value and alpha of this particular node, you have to use the pointer notation. So node alpha, and then you select the capital B, and node sorry, node dot value, and let's say 400. And if you want to display it, again same syntax, cout node alpha, and cout node value, right? And I'm not going to go into the details of what is a heap and what is a stack memory part, because that's part of the introduction to programming course, where you actually learn how to create two different types of variable. One variable can be created in a stack, which is called automatic storage, and as long as the function in which that variable has been declared exits, that memory is lost, right? You don't have access to that memory. But if you create a variable using the new keyword, new operator, that means even if the function exits, that memory still is reserved. And what is the consequences of that is, if you have to free that memory yourself. So before closing the program, you have to use the delete word, and you have to tell the operating system that delete the node. Delete doesn't mean delete the value. Delete means I no longer need that memory in my program, and you can reclaim that memory, because memory is managed manually in C++, unlike Java and C#, where we have the concept of garbage collection. So you have to explicitly release the memory that you have acquired using the new keyword. I hope that you understand what is the difference between a pointer and a variable, and what do we mean by pointer to a struct. And similarly, you can even create a pointer to classes. Let me comment out this line and create a new class, and I'm going to call this class, let's say point, and it has those 2x and y coordinates, and let me give it a constructor public point. This is a default constructor. Let me give it a parameterized constructor as well, int x, int y, and then again I'm gonna remove this and say this dot x, right, and this y equals y, and you can get the values in get x, return x, and I could make it constant because this does not change the value of x but rather returns the value. Similarly, I'm going to get y and make it constant as well, just to use some of the concept we already studied, and return y. And in this main function, I'm going to create a dynamic object, an object on the heap, and that means that I'm going to say the name of the class point in star, and then I'm going to say point equals new point. This is the new syntax, point, and I'm going to say, for example, 100 and 200. The value of the x for this point is 100, and the value of the y for this pointer is 200. And if you want to display the values, you can call the getx and getY functions that I declared. So you can say point, again this time the arrow symbol getx, because it's a pointer, not an object, and then point get y, and then So let me save the program, recompile the program and run it, and you will see the value of x coordinate and the value of y coordinate. So that's it for today's demo. I hope it's clear, and if you have any problem, let me know. Thanks for watching.